9. So all of you keep reading. Properties of anode rays. So also anode rays also we can call it as a what? Everybody? Canal,
Canal rays.
or we can say it is the positive rays. Okay. So before going to say that, so just I want to mention few points. So we all knows that in any atom, now after these experiments by Mr. J.J. Thomson and as well as Eugen Goldstein. So after this, both two experiments, so we have been a fundamental material, any kind of matter if you have been taken, or a subatomic particle. So definitely it is carrying a negative charge and as well as a positive charge. So if it is a negative charge, which we used to call it as, what we used to call everybody? Electron.
Electron.
And what is the charge of one electron, everybody? Charge of one electron is 1.6 into 10 power minus 19 coulomb. And what is the mass of electron? Anybody? Mass of electron. This is the charge. Charge of electron is this. What is the mass of electron? Yesterday also I told you. So 9.1 into 10 power minus 28 grams. Same way if I have taken, there is another subatomic particle which is present. The one subatomic particle is electron. In any kind of atom, if you have been taken, one subatomic particle is electron. And there is another subatomic particle, that is only we used to call it as, what is to call everybody? Proton. So remember, by this time we people don't know the neutrons. So you people don't know. Do you all understand what I am saying? So by this time we people don't know what is neutrons. So you have to remember that neutrons are not known to us by the time of discovery of electrons and discovery of protons. I hope you all understand what I am saying. Everybody? Clear, everybody? So only what is known to us? All of you? Only protons and electrons. So now protons, if you have been taken, what is the charge of proton? Electron charge is minus 1.6 into 10 power minus 19. And charge of proton is how much, you know, guys? It is a positive charge of 1.6 into 10 power minus 19 coulomb. That is the reason why the atoms are stable. Why the atoms are stable in nature. And what is the charge of atoms? Anybody? Atoms are what? Atoms are what? Electrically. You have studied atoms are what electrically?
Stable.
Understanding? So electrically they are neutral in nature. There is a neutral charge. They do not have any positive charge or negative charge. Why? The number of protons is equals to what? Number of protons is equals to what? Number of electrons. So both charges same only, correct guys? Suppose I'm having positive charge 1.6 into 10 power minus 19. Negative charge 1.6 into 10 power minus 19. So both will get cancelled. So finally what is that? Number of protons is equals to number of electrons. So charge is balanced. That is the reason atoms are, what is the charge of an atom? Everybody. Electrically? Yes, please. Atoms are what? Electrically
Stable.
stable in nature.
Neutral.
They do not have any charge. They are stable in nature. I hope you all understand, everybody. And what is the mass of proton? Anybody can tell? The mass of proton is actually 1.67 into 10 power minus 27 kg. So it is how many times bigger than electron? Everybody. The mass of one proton is approximately how many times? All of you. Mass of one proton is equals to how much, guys? 1857 times of mass of electron. Mass of electron. That is the reason we are neglecting the mass of electron. Am I right, guys? Please respond, everybody. Is it yes or no?
Yes,
All of
sir.
you? Yes. So 1857 times the mass of electron is lesser than, mass of electron is lesser than that. That is the reason we people will consider the mass of electron is negligible. Is it okay, everybody? Do you all understand what I'm saying? All of you?
Yes, sir.
Yes. So please remember that. Anybody having any doubt, you can ask. So now let us start with the properties of anode rays. So anode rays means we used to call it as a what? Anode rays also we can call it as
Canal or
anode
positive.
rays or positive rays. Okay. So first thing, again same. Like cathode rays, they will always travel in a straight line. Am I right or wrong? Same way, cathode rays or anode rays, both will travel in a straight line. Please write it. Travel in a straight line. So that is the first property. Second property. So they are having what charge, everybody? They are having a what charge? Yes, please.
Positive charge.
Positively charged. That is what. Everybody, I hope you all understand. Everyone clear?
Positive.
Yes. Do it fast. Anything doubt? Please let me know. I hope you all understanding. Everybody.
Yes, sir.
Yes, sir.
Do it. Next property. So what is needed only we'll study. So next. So now this positive charge is basically, see, electrons does not depend on what kind of gas we are making. But here you can see the protons are making depend on two things. Either it is a ideal gas or it is a normal gas. Because if it is suppose hydrogen gas, yesterday we have studied how many steps it has. Two steps it has. Am I right or wrong? If it is this ideal gases, directly we'll get the protons. Am I right or wrong, guys? We have done or not? Everybody?
Yes, sir. Yes,
Yes.
sir.
So that is what you have to remember. Okay. So always remember these anode rays is depend upon nature of a gas which you are taking. So that is the third one you have to remember. Third property is depends upon nature of a gas. Depends upon nature of a gas. So what gas we are filling inside the tube, that is what it is. Okay, everybody? All of you understanding? Yes, please.
Yes, sir. Yes, sir.
Next, what is the color? What is the color they will produce? Yesterday we studied. Everybody has to study. What is the color they will produce?
Red fluorescent.
Yes,
Red fluorescent.
they will produce red glow. So that is what it is. Understanding? Next, they are what? Lighter particles or heavier particles? Everybody. They are
Heavier
what
particles.
particles? Heavier particles. So write it. That's all. So these are the important particles for us. Of course, even you studied magnetic forces also. That is all is not needed for us now. So 11th class, 12th class we'll study. So we'll do it. Okay. Yes, that is what. So this is what is about it. So anybody having doubt, you can ask me. So these are the properties which we need it. So now if you all understand this one, then I hope you all understand what is the meaning of cathode rays and what is the meaning of anode rays. Now we are going to discuss properties of protons. Properties of protons. Okay. So question number 1. First property. Proton arises from the word proton arises from the word protium. Protium. Again, this chapter will study this. Protium, which represents H atom, hydrogen atom. So do you all remember why hydrogen atom? Anybody can tell? Why hydrogen atom? Hydrogen atom having a specialty. I already told, yesterday also I told you. Anybody? What is the hydrogen atom specialty, guys?
It only has protons and electrons.
Yes. Yes, it has only protons and electrons. No neutrons. And that is the reason the only element whose atomic number is equals to mass number. Am I right or wrong? Yesterday also I told you. Am I right, guys? Please respond, everybody. Clear? All of you? Yes, please.
Yes, sir.
That is what. So that is the reason it is called as a protein. We will study this chapter again. Isotopes will come. By the time we will study that. Next. They are positively charged. They are positively charged. So next, the charge of proton is equals to what? Everybody. A charge of proton is equals to something. Everybody. Charge of proton is equal to the what? Charge of
Electron.
charge of electron. So what is the charge? Both the charge is how much? 1.6 into, you should learn this value by this time. 1.6 into 10 power minus 19.
Minus 19.
Minus 19.
Coulombs.
Clear, everyone? So please make it. Understand? Mr. Sam, Pradhana, Padma,
Yes, sir.
Alvin, I'm calling you. Next. The mass of proton is almost equals to the mass of proton is almost equal to the mass of hydrogen. Mass of hydrogen. Why, guys? Anybody can tell? Because hydrogen is having only how many protons? Hydrogen is having only how many
One.
protons? Only
One.
one proton. That's all. Clear, everybody? Understanding? Hydrogen has only one proton. So that's why the mass is equals to the proton. Do you understand? Prithvi, Princey, everybody? So any doubt you can ask. Yes. So that is
Yes,
what.
sir.
Next. They are present where? They are present inside the nucleus. They are, and you write it, what is the mass amount? 1.67 into 10 power. 10 power.
Minus
Minus
27.
24 grams. Minus 24 grams. Or kg, minus 27 kg. So please note it. 1.67 into 10 power minus 27 kg or grams. Mari, understand? Next. They are present inside the nucleus of the atom. Yes, please. Next, the positive charge of nucleus is due to the presence of whom, guys? Presence of? Why the nucleus is
Protons.
having positive charge? Because of nucleus. Yes, please.
Protons.
Protons. That is what you have to remember. I hope you all clear. Anybody having any doubt, please let me know. All of you understand? Yes, please.
Yes, sir.
Make it. Till here completed. Any doubt you can ask. Completed? All of you understand, Amma? Next, structure of atom. So this is what is all about protons and electrons. Now we are going to study. So by this time, there is no discovery of neutrons. So only we are going to study about protons and neutrons. So until the models which are going to complete up to the alpha particles, that is what Rutherford model. So all the models we have, after completing that only, we are going to get a concept of a Bohr's atomic model. So after that only, we are going to study the discovery of neutrons, because till 1920, people used to believe that 1920 means during the time of World War One, people used to believe that matter contains only two. One is, that is what, atoms contains only two. One is electrons, another one is what? Protons. But after 1920 only, it has been discovered that there is another third subatomic particle of matter, which is called it as neutrons. But of course, that we will discuss later. So now we are going to directly jump into the concept of, what is the next concept, everybody? That is only called it as structure of atom. So now, after identifying the subatomic particles, so the curiosity rises to the peaks for the scientists, and they started comparing the structure of atom, and they started forming the thesis, which is a theories, different varieties of theories to define the structure of atom, how the structure of atom is there, and how these protons and electrons are present inside. So that is what. So the many people came forward to put the theories after Mr. Dalton suggested in chapter number 2. Sorry, chapter number 3. Mr. Dalton said first point. Anybody can tell what is the first point of Mr. Dalton? All of you, I want to know. What is the first point of Dalton's? Go through that and tell me. Kavya, Sangamitrai, Alfin.
Atoms are the
Atoms
not
are indivisible. Atoms are indivisible. So Dalton in his atomic theory suggested that an atom is indivisible. So later on, days are passing, this concept was disagreed or discarded due to the discovery of electrons and protons. So the electrical neutrality of the atom proves that electrically neutrality of the atom proves that there are equal number of what? Any atom contains what? Everybody. Any atom contains what? Equal number of protons and equal number of what, guys? Speak loudly.
electrons.
Equal number of electrons. So the number of protons and electrons are equal. But there is a question. How these electrons and protons are arranged in an atom? So this led to many scientists to propose a different atomic models. So that model describing the arrangement of different subatomic particles in an atom, that is what we used to call it as atomic models. So before going to study what is the models of atom, structure of atom, let us study the definition of atomic models. So write it, everybody. So what is the definition of atomic model? Anybody can tell? Everybody? Yes, please. All of you? What is atomic model? So just describing of the arrangement of electrons and protons. That is what we used to call it as atomic model. If you are suggesting some model, that is what is a model. If you say something, that is what. If it is a valid, we'll consider it. If not valid, we'll say it is wrong. So that's all. So right, the models describing the models, the models, the models describing the arrangement of different subatomic particles. Per day one you learn, that is enough. What is the advantage, what is the comparison, what is the limitations, that's enough. Because one day you learn, only you have three models, definitely three models, every exam at least one model they'll ask. So just one model per day, it is enough for us. Subatomic particles in an atom are called atomic models. So who is the first scientist suggested atomic model? Anybody can guess? Yes, please. A man who discovered the electrons. Yes. Who suggested first model?
Thomas.
J.J. Thom.
J.J. Thomson Mari. Thomas Illamari. J.J. Thomson. Okay, that is what. First. The first atomic model is given by whom, guys? J.J. Thomson. Okay, so keep heading. First, that is only our target. So the model is name is Thomson atomic model. Thomson's atomic model. Also, we can call it as a plum pudding model. Plum pudding model. Also, we can call it as watermelon model. So many things we can. So Thomson's atomic model or plum pudding model. So let us talk about this model first, and later I will go with the comparison with the plum pudding and comparison with the watermelon. Are you clear, everybody? So first write what is this and then we'll proceed it. Okay, right. The model of atom is given by the model. Ma, do you all understand, Ma? The model of atom given by who has given everybody? J.J. Thomson. J.J. Thomson is also known as the plum pudding model. Plum pudding model. My exam theoretical part questions will come. You have to write neatly. Otherwise, full mark you cannot. Plum pudding model of an atom or watermelon model. Watermelon model. Tamil, what do you say watermelon? Yes? Okay. Clear, everybody? All of you understand? So first point. Clear? Anybody having any doubt, you can ask me. All of you clear, guys? First point. An atom is considered as positively charged. An atom is considered, first point, 3 points is there. Learn 3 points, very, very important. An atom is considered as positively charged sphere. Positively charged sphere because positive charge is uniformly distributed. Positive charge is uniformly distributed. While you are comparing, you will understand. Distributed. Point number 1. Point number 2. And electrons are embedded. What do you mean by embedded? Anybody can tell? The electrons are embedded. What do you mean by embedded? Speak, guys. You all know, so don't not tell me. Embedded means arranged. Embedded, arranged in this positively charged sphere. How many of you ate the Christmas cake? Many of you have had the Christmas cake. Am I right? Yes, please. Nobody? Nobody had a Christmas cake. This is very bad. So Christmas cake, how many of you had this cherries? This what we can say is
Plum cake.
yeah, plum cake. We can see is that inside something will be there, correct, Mari? That with the papaya they will make. What is that called as? Yes, that normally we'll put correct many things. Yeah. So that plum cake you all can see is we are having different this kismisses and that what you can say like that sweet kind of things and all. So that is only call it as negatively charged, and the entire plum cake is considered as positive charge. Of course, we'll discuss now. I'll show you. Clear, everyone? So that is what. So then the third point is only 3 points regarding this. So this is a very simple model. So in an atom, the total positive charge The total positive charge, actually the J.J. Thomson model, only third point is valid. The total positive charge is equal to the total negative charge. Total negative charge. What is the purpose? Anybody can tell me? To maintain what? Anybody? To maintain the what? Why it is having equal amount of positive charge and equal amount of negative charge? To maintain the what?
Electrically stable.
Yes, electrical neutrality. That is what I wanted. I hope you all clear. Any doubt? Anybody can ask. Understand, Amma? Yes.
Yes, sir.
Yes, sir.
Any doubt you can ask. Okay, all of you. So write these 3 points. If you write these 3 points, then we'll proceed further. I hope all of you clear.
Yes, sir.
Now, so now keep reading, everybody. Comparison with the plum pudding. Comparison with the plum pudding. That is the first thing, A point. So Mr. J.J. Thomson compares the atom with whom? With the plum cake. Plum pudding. Okay, everybody. So let us see that. I'll show you and then I'll explain so that you all understand. So you can go through that and you can make it. So what is that? He comparison with what?
Plum pudding.
Yeah. Comparison with the plum cake. Plum pudding. Okay. So how he has been compared? Oh, it is not compare plum pudding with that. So basically you all consider, let me consider this is what it is. So he considered this is, we all know plum pudding model. Am I right, guys? Please respond. Yes or no, plum cake. So he considered this entire cake is actually a positive charge. Entire cake is a positive charge. And the cherries and the Christmas, whatever you are seeing here, that is what he considered as a, what he consider, everybody? Negative charge. This is what exactly you all can notice it. So entire cake he has been considered positive charge, and the elements, the extra things what we are putting, which is embedded, that embedding things, that is the meaning of that arrangement is only we used to call it as embedding. That embedded things is considered as a negative charge. I hope you all understand. So this is the comparison of the space filled with, you can exactly space. So the space filled with the empty space and all is considered as a what? Positive charge or negative charge? That empty space.
Positive charge.
Positive charge. The empty space, please mention that. Draw it and make one circle. Make one circle and arrange negative charge yourself. So this is what embedding this. So this is what the empty space. The space is filled with what charge, guys? Space is filled with what charge? Everybody. Space is filled with a
Positive charge.
positive charge, and negatively charged electrons are, write neatly, negatively charged electrons are, negatively charged electrons spread throughout. Spread throughout. I hope you all understand, everybody. Boys, please respond, guys. All of you understand, Amma?
Yes, sir.
Yes.
Yes, sir.
So now, negatively charged. In cake, you compare. Who is the, in the pudding, this Christmas pudding, who is the negative charge? Anybody? Who is a negative charge? The cherries, if you take the kismis. Hey, what is that? Call it as that colorful one will be there, correct? I forgot the name actually. What is that? Call it as? Which is made with a papaya. Anybody? Ma?
Sir, tutti frutti.
Yes, Mukesh Kalyan said, Mukesh, Prudhviya. Yes, yes. That tutti fruitis. The tutti fruitis only we used to call it as a negative charge. They are actually stuck inside, correct? They're inside the cake. That is what we used to call it as a negative charge. And remaining entire cake. You see here, kismis, this tutti fruitis, they are actually negative charge. And remaining cake is call it as a what? Yes, please. Positive charge. Understand everybody? So that is why the Thomson model resembles. What do you mean by resembles? Anybody? Learn the word resembles. 10th class again this will come in the physics. Resembles. What do you mean by resembles? Similar. Similarities. Meaning of. Resembles pudding. That is what you have to remember. Thomson's model resembles pudding. I hope you all understand, everybody. Actually, we used to say Christmas pudding. That is what you have to remember. So note it, the dry fruits represent the electrons and the whole pudding has positively charged. That is the two statements you have to write. What is you have to write it, everybody? Write it. What you have to write? In J.J. Thomson compared the atom with a Christmas pudding. Compare the atom with a Christmas pudding. With the what? Christmas pudding. Christmas pudding in which the dry fruits represents the electrons and the whole pudding as positively charged atom. Whole pudding is as what, everybody? Positively charged? Yes, please. Positively charged atom. You understand, everyone? Yes, please.
Yes, sir.
Do it. Any doubt? Anybody can ask. All of you understand? Clear? Yes? So the next model which is compared is, you all know, comparison with the watermelon. How many of you know watermelon? What we can say is watermelon, Tamil? Summer will eat, correct, guys? Yes, please.
Yes, sir.
Yeah. So that is what is the second. Now I want to show you exactly. Yes, this is exact good picture. It is, we can. So you all experience it, that edible material, what you can eat, that red edible part of watermelon represents the what charge? Anybody can tell?
Positive charge.
Yes, positive charge. Clear, everybody? All of you? Mari, Lingesh? So the red edible part, which is considered as a positive charge, and the seeds which are arranged, is considered as a what? Yes,
Negative charge.
negatively charged. Just. So write that point. He also compared the atom. Next, second point. Comparison with the watermelon. Comparison with the watermelon. I hope you all understand. Anybody having any doubt, please ask me. Learn this one per day. 3 points. Comparison with the plum pudding. Comparison with the watermelon. You have to draw diagram also. So second one. Everybody. Comparison with the watermelon. Join back and we'll continue limitations of Thomson model so that this will completely over. First, right. He also compared the atom with the watermelon watermelon. He also compared the atom with the watermelon. Atom with the watermelon. The red edible part. The red edible part. What do you mean by edible part? Anybody? Which we can eat. The edible part of watermelon represents positive charge